Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida.
So in this section we will deal with all things pertaining to artificial intelligence, otherwise known as AI.
Every year in November and the following year in June, the top supercomputer list, the top 500, are announced, presented, and it looks very much to be a go for the US to claim the #1 spot again, which it hasn't had in quite a long time. So this will be coming up in a few weeks, the list. So let's read this because I think it's quite interesting. The summit and running at the Oak Ridge claims first exascale application. If you don't know what exaflop computing is, then you need to look it up because it hasn't happened yet, but it's about to happen in the next few years. The Department of Energy's 200 petaflop Summit supercomputer is now in operation at Oak Ridge National Laboratory. The new system is being touted as the most powerful and smartest machine in the world. It's a given that NSA has something more powerful than this. They've got the money, they'll be running the energy costs to run it at a higher level, but this is what is the commercial top of the line, and which are usually run by governments and not entities under that, the top big machines anyway. The new system, we've just read that, and unless the Chinese pull off some sort of surprise this month, the new system will vault the US back into first place on the top 500 list when the new rankings are announced in a couple of weeks. Although the Department of Energy has not revealed Summit's lip track result as of yet, the system's 200 plus petaflop peak number will surely be enough to outrun the 93 petaflop lip pack mark of the current top 500 champion, the Chinese Sunway Tianjin Light, however you pronounce that. Even though the general specifications for Summit have been known for some time, it's worth recapping them here. The IBM system is comprised of 4,608 nodes, each one housing 2 Power 9 CPUs and 6 NVIDIA Tesla V100 GPUs. Interesting. The nodes are hooked together with a Mellanox dual rail EDI InfiniBand network delivering 200 gigabits per second to each server. Assuming all these nodes are fully equipped, the GPU alone will provide 215 petaflops at double precision. Also, since the difference between double precision and single precision is the amount of decimal places you get after the unit. Also, since each V100 also delivers 125 teraflops of mixed precision tensor core operations, the system's peak rating for deep learning performance is something on the order of 3.3 exaflops. These exaflops are not just theoretical either. According to the director, won't pronounce the name, even before the machine was fully built, researchers had run a comparative genomics code at 1.88 exaflops using the tensor core capability of the GPUs. The application was rummaging through genes looking for patterns indicating a certain condition. This is the first time anyone has broke the exascale barrier, said Zakaria. Okay, we've got the name right. Of course, Summit will also support the standard array of science codes the Department of Energy is most interested in, especially those having to do with things like fusion energy, alternative energy sources, material science, climate studies, computational chemistry, and cosmology. But this is open science system, but since this is actually an open science system available to all sorts of research, then that frankly has nothing to do with energy, Summit will also be using it for, get your English right, healthcare applications in areas such as drug discovery, cancer studies, addiction, and research into other types of disease. In fact, at the press conference announcing the system's launch, Zakaria expressed his desire for Oakland Ridge to be the CERN of healthcare data analytics. The analytics aspect dovetails nicely with Summit's deep learning propensities, in as much as the former is really just a superset of the latter. When the DOE first contracted for the system back in 2014, the agency probably only had a rough idea of what they would be getting AI-wise, although IBM had been touting its data-centric approach to supercomputing prior to pitching its Power 9 GPU platform to the DOE. The AI machine learning application space was in its early stages. Because NVIDIA made the decision to integrate the specialized tensor cores into the V100, Summit ended up being an AI behemoth as well as a powerhouse high-performance computing machine. As a result, the system is likely to be engaged in a lot of cutting-edge AI research in addition to its HPC duties. For the time being, Summit will only be open to select projects as it goes through its acceptance process. In 2019, the system will become more widely available, including its use in the innovative and novel computational impact on theory and experiment programs. At that point, Summit's predecessor, the Titan supercomputer, is likely to be decommissioned. Summit has about 8 times the performance of Titan with 5 times better energy efficiency. When Oak Ridge installed Titan in 2012, it was the most powerful system in the world and is still fastest supercomputer in the US. Well, now for the second fastest. Titan has NVIDIA GPUs, but these are the K20X graphics processors, and their machine learning capacity are limited to 4 single precision teraflops per device. Fortunately, all the GPU-enabled HPC codes delivered for Titan should port over to Summit pretty easily and should be able to take advantage of the much greater computational horsepower of the V100. For IBM, Summit represents a great opportunity to showcase its Power 9 GPU AC922 server to other potential HPC and enterprise customers. At this point, the company's principal success with its Power 9 servers has been with systems sold to enterprise and cloud clients, but generally without GPU accelerators. IBM's only other big win for its Power 9 GPU product is the identically configured Sierra supercomputer being installed at Lawrence Livermore National Laboratory. The company seems to think its biggest opportunity with the V100 equipped server is with enterprise customers looking for GPUs for database acceleration and developing deep learning applications in-house. Summit will also fulfill another important role, that of a development platform for exascale science applications. At the last petascale system at Oak Ridge, the 200 petaflop machine will be a stepping stone for a bunch of HPC codes moving to exascale machinery over the next few years. And now with Summit up and running, that doesn't seem like such a far off project. After all, it's just 5 times from where we are. So one can expect exaflops somewhere about 2022. I mean, there is no roadmap to a NVIDIA GPU come 2020 because of the need for extreme ultraviolet lithography, which is not totally commercialized yet. But by 2022, if they get their act together, we should see a whopping great boost in AI capabilities, even compared to this machine. So that's a big step up for the US and a big step up for AI.